chemical reactions and equations. So first of all, we'll begin by defining what a chemical equation is. So when we talk about chemical reaction, basically a chemical reaction is a chemical change. Whenever there is a chemical change, one substance converts into some different substance. So whenever a chemical change takes place, we say we have a chemical reaction for that. To denote that, we use a chemical reaction. So chemical reaction is a chemical change in which matter changes into a new substance or substances. Maybe not one, but some new substances are formed. So this is how we define a chemical reaction, and a chemical reaction is denoted by a chemical equation. We'll come to chemical equation as well. So activity. Okay. In the first activity, what are we doing is that we are taking a magnesium ribbon. So a ribbon, magnesium ribbon, we are holding it with a pair of tongs and we are burning it. As the magnesium ribbon burns, we see that there are ashes being collected down. So what does it denote? We'll talk about that. So first activity, so first bullet, clean a magnesium ribbon about 2 centimeters long by rubbing it with sandpaper. Then hold it with a pair of tongs burn it using a spirit lamp or burner and collect the ash so formed in a watch glass. Watch glass is basically like a small plate, but that is your glass material, and where your anything like this ashes are being collected. Now what we do is we burn the magnesium ribbon keeping it as far as possible from the eyes. Okay, so after this, as the magnesium burns, what we see, magnesium ribbon burns, we see that ashes are coming down. So what happens in this? What we conclude by this activity is that Magnesium ribbon burns with a dazzling flame and changes into white powder. And this powder is magnesium oxide. It is formed due to the reaction between magnesium and oxygen present in air. Okay. So oxygen is present in air, and when we are burning magnesium, what are we doing is we are providing the necessary heat so that magnesium can react with oxygen. As magnesium reacts with oxygen, what happens is magnesium oxide is formed. Okay. Chemical equation now we'll use to denote these reactions. So chemical equations, first we can denote as word equation, which is not very preferred because word equation doesn't give us the exact details. Like the word equation for the previous activity that we discussed, in this activity what happens is the magnesium reacts with oxygen that was in air. So magnesium reacts with oxygen to form magnesium oxide. So we see that magnesium plus oxygen forms magnesium oxide. So this one on the left side of the arrow is called the reactants, as they are reacting, and on the right side is called the product because this is the final product that we are getting. Okay, now this is not very feasible in denoting. So chemical equations can be made more concise and useful if we use chemical formula instead of words. Just like this reaction, we can write this as magnesium is Mg plus oxygen O2 gives magnesium oxide MgO. Just a quick recap of how did we get MgO. Magnesium's valency is 2, oxygen's valency is 2. 2 ones are, they cancel out, 1 goes to oxygen, 1 comes to magnesium. So Mg1O1, so MgO. Now when we look at this reaction, on the left hand side we see 1 magnesium, right hand side 1 magnesium, left hand side 2 oxygen, right hand side 1 oxygen. So this equation is not balanced. A balanced equation is one which has the same number of each of the elements. each atom of each element on the left hand side and on the right hand side of this equation equal. Here magnesium 1, it's fine. But oxygen, here we have 2 and here oxygen we have only 1. So this is not balanced. So first of all, we'll learn why do we need to balance. Okay. So what is a balanced equation? Solution. So a balanced equation is one in which the number of atoms of each element is the same on the side of reactants and on the side of product. So whenever the number of atoms of each element, like oxygen here on the left side, on the side of reactants is only 2, and on the right hand side, that is on the side of products, it's only 1. So this is not equal. The number of atoms of each element is the same on both the side of the reactant and on the side of product. So this reaction is not balanced. Such a reaction, we call this type of reaction as a skeletal chemical equation. So this is a skeletal chemical equation. Now, how do we balance a reaction? Okay. And second question before that is, what is the need, or why should an equation be balanced? So we saw what a balanced equation is. We saw oxygen is on the left hand side 2, on the right hand side is 1. So it's not balanced, it's called a skeletal chemical reaction or a skeletal chemical equation. Now why should we balance this equation? So all equations must be balanced in order to comply with the law of conservation of mass. Which explains that matter is neither created nor destroyed in a chemical reaction. So whenever we say that a chemical reaction has taken place, it abides the law of conservation of mass. So if the left hand side has lesser mass or more mass, like here the left hand side will have more mass and the right hand side has less mass, this cannot happen. By the law of conservation of mass, what should happen is left hand side whatever the total mass is and the right hand side the total mass, it should be equal. that is the total mass of the elements present in the reactants of a chemical reaction has to be equal to the total mass of the elements present in the products. Okay, now let's see how we balance it. So let's come to this equation itself. So number one, we are taking magnesium reacting with oxygen to form magnesium oxide. Okay, so element, we have two elements, magnesium and oxygen. So number of atoms in left hand side, number of atoms in right hand side. So in the left hand side magnesium is 1, on the right hand side magnesium is 1, left hand side oxygen is 2, right hand side oxygen is 1. So to balance this, what we do, whenever you balance a reaction, always take a pencil and an eraser and balance them, because while balancing you are supposed to make some mistake here and there, or you might need to erase something. That is why always use a pencil and a eraser. So first of all, oxygen is only 1 and here oxygen is 2. So in the product side, what we need to do is we need to make the oxygen 2. So in order to make oxygen 2, what we do is we put over here 2. We cannot put oxygen over here because this is a compound. So you cannot change the property of a compound. So we cannot put 2 over here. So what we do is we put 2 in the front. Now this 2 is not only for oxygen but also for magnesium. Magnesium was 1, 1 into 2, magnesium is now 2, oxygen 2. So oxygen 2 balanced, but while we put 2 over here, magnesium became 2. So we need to balance magnesium as well now. So magnesium on the right hand side is 2, magnesium on the left hand side is 1. So we put a 2 over here. So we have 2 magnesium, 2 oxygen, 2 magnesium, 2 oxygen. So this is how we balance a reaction. Second example. PbNO3 2 plus Ki. This is aqueous solution. This is aqueous solution. When they react, they form PbI2 plus KNO3. This is also aqueous and this is solid. So to balance this, first of all, what we are going to do, just like the previous, we'll write the elements, number of atoms in left hand side, number of atoms in right hand side. So element, number of atoms in left hand side, number of atoms in right hand side. So we have lead, Pb, nitrogen, oxygen, potassium, iodine. So in the left hand side, lead is 1, nitrogen, see this 2 is for both of them now. Nitrogen, and 1 into 2 is 2. Oxygen, 3 2s are 6. Potassium, 1. Iodine, 1. And the right hand side, PP1, I, we have 2. Potassium, 1. Nitrogen, 1. Oxygen, 3. Okay. So see, nitrogen on the left hand side we have 2 and on the right hand side we have 1. So we'll write the equation again first. Pb NO3 2 plus Ki gives PbI2 plus KNO3. So this is aqueous, solid, aqueous, aqueous. Okay. So lead is 1, lead is balanced. Nitrogen here we have 2, on the right hand side we have 1. So to balance this, in the right hand side we'll multiply this compound having nitrogen by 2. So now some things have changed. So nitrogen became 2, so nitrogen now balanced. Potassium balanced. Oxygen, 3 2s are 6, 3 2s are 6. So oxygen also balanced. But potassium, here we have 2, here we have 1. So in order to balance now potassium, because potassium changed, what we'll do is we'll multiply this with 2. So we have 2 potassium, here also 2 potassium. With this iodine becomes 2, here iodine is 2. So now all of these elements are balanced. Pb1, Pb1, N2, N2, O6, 3 2s are 6, K2, K2, I2, I2. So all of these are balanced. So with this, this equation is balanced. So in the first equation, we saw that oxygen reaction with oxygen, flames are produced. So it is a burning reaction. It produces or releases energy. So here we are seeing that when two liquids or two solutions react, it has the capacity of producing a solid. So there can be a change in state. Third example that we see is of zinc reacting with hydrochloric or sulfuric acid. We can take any one. Say I take sulfuric acid, H2SO4 gives a zinc sulfate, and with this releases hydrogen. Hydrogen is a gas. So if we see element, number of atoms in left hand side, number of atoms in right hand side, so first we have zinc, hydrogen, sulfur, oxygen. So left hand side zinc 1, hydrogen 2, sulfur 1, oxygen 4. Right hand side zinc 1, hydrogen 2, sulfur 1, oxygen 4. So see, each of the elements number in the left hand side and right hand side matches. So therefore we do not need to balance this equation. The given equation itself is balanced. So zinc plus H2SO4 gives ZnSO4 plus H2. So this is already balanced. In this reaction, we note that hydrogen is evolved as a gas. There was no gas before. This was liquid, a dilute solution of hydrosulfuric acid, and this was zinc, which was metallic, so solid. So this reacts to form a gas. So in some reactions, it may also be accompanied by evolution of gas. The next reaction, number 4, that I am going to balance is Fe plus H2O gives Fe3O4 plus H2. Okay. So again we begin in the same way. Element, number of atoms in left hand side, number of atoms in a right hand side so we have iron, Fe, hydrogen, oxygen. Left hand side Fe is 1, right hand side Fe is 3, hydrogen 2, hydrogen 2, oxygen 1, oxygen 4. So first of all we balance Fe. We have 1 in the left hand side, right hand side we have 3, so we multiply with 3. So 3 ones are Fe balanced. Now hydrogen is 2, 2, fine. Oxygen is 1 in the left hand side, 4 in the right hand side. So we need to multiply oxygen by 4. So oxygen also balanced. But in the process what happens is 4 2s are we get 8 hydrogen. So here also we'll multiply with 4 for hydrogen because 4 2s are 8 hydrogen. So left hand side, right hand side, hydrogen also balanced. So this is how we balance a reaction. So I forgot to repeat the reaction. This is our question for your answer. First you will write this table and then you will balance it. Hydrogen is always released as a gas. 3, 4 and 4. Okay. Now as we have seen this many reactions, now we have something to conclude from these reactions as well. So the next thing that we are going to discuss is the characteristics or the indications that shows that a chemical reaction has taken place. So characteristics or indications that determine whether a chemical reaction has taken place. Number 1 is the change in state. So just like we saw over here, we took two solutions and we got a solid and another solution. So solid form is change in state. So this is one example. Here also we saw this was solid, this is solution. So solid and a solution or liquid, they react to form this solution, and what is happening is gas is evolving. So there is change in state. Second thing, thus we can conclude there can also be evolution of gas. Third thing, many reactions are also accompanied by change in color. And we know that many reactions, just like you can consider burning or any combustion, when we burn wood, what happens is we feel a lot of heat energy. So change in temperature is another characteristic that determines that a chemical reaction has taken place. Some reactions absorb heat energy, so temperature will decrease, and some reactions evolve or it releases heat energy, their temperature increases. So with this we come to the end of today's lecture. Thank you.